This is how to wire an Ethernet cable. 8 tiny wires, 1 RJ45 plug, and a color order that has to be exact. Get that order right, and you have a network cable that just works. Get it wrong, and nothing connects at all. So this is how to wire Ethernet cable properly, end to end. The 4 pairs, the 2 standards, the pinout, the crimp, and the test. By the end, this finished plug will make complete sense, and you will be able to wire one yourself. Start with the cable itself. Cut one open, and you find 8 wires, but they're not random. They come in 4 twisted pairs. Each pair shares a color. There's an orange pair, a green pair, a blue pair, and a brown pair. Within every pair, one wire is a solid color, and the other is white with a matching stripe. Solid orange and white orange. Solid green and white green. Blue and white blue. Brown and white brown. Why twisted? The twist is what fights interference. 2 wires carrying opposite signals, wound tightly together, cancel out the electrical noise around them. That is the whole reason Ethernet stays fast and clean over long runs. 4 pairs, 8 wires. That is every Ethernet cable, from a cheap patch lead to in-wall Cat6. Now, the part everyone gets wrong, the order those 8 wires sit in at the plug. There are 2 official standards, and they differ by exactly 1 swap. This is T568B, the common one by far. Pin 1, white-orange. Pin 2, orange. Pin 3, white-green. Pin 4, blue. Pin 5, white-blue. Pin 6, green. Pin 7, white-brown. Pin 8, brown. T568A is almost identical. The only change, the orange pair and the green pair trade places. So pins 1, 2, 3, and 6 move. Pins 4, 5, 7, and 8 stay put. Here is the rule that actually matters. Pick one standard and use the same one on both ends of the cable. Do that, and you have a normal straight-through cable, a laptop to a switch, a router to a wall port. So which pin is pin 1? Hold the RJ45 connector with the little plastic clip pointing down and away from you, and the gold pins facing up. Now pin 1 is on the left, and pin 8 is on the right. That is it. Flip the plug the wrong way, and your whole order reverses. This is the classic mistake. The wires seat into those 8 channels in color order and run to the very front. There, the gold pins bite down through the insulation to make contact. Left to right, 1 to 8. Get the orientation right, and everything else follows. The same standard on both ends gives you a straight-through cable. That covers almost everything you will ever plug in: computers, consoles, printers, access points, all talking to a switch or a router. There is a second type, the crossover cable. Same idea, but you put T568A on one end and T568B on the other. That swap crosses the transmit and receive pairs, which used to be needed to link 2 similar devices directly. 2 computers or 2 switches back to back. Here is the good news. Modern gear has a feature called auto-MDIX, which flips those pairs automatically inside the port. So you almost never need a crossover cable anymore. When in doubt, wire straight through on both ends and move on. Now the crimp, where the wire meets the plug. 6 steps. 1. Strip the outer jacket back about an inch without nicking the thin wires inside. 2. Untwist each pair and straighten the 8 wires out flat. 3. Line them up in your chosen order, left to right. This is the step that decides everything, so take your time. 4. Hold them tight and flat, and trim the ends off clean so all 8 are exactly the same length. 5. Slide them into the RJ45, keeping the order, and push until each wire hits the very front of the plug. The outer jacket should end up clamped inside the connector, not outside it. 6. Drop it into the crimp tool and squeeze. That drives the gold pins into the wires and locks the jacket in place. Strip, untwist, order, trim, insert, crimp. The same 6 steps every single time. A few small things separate a cable that works from one that lasts. Keep the twists as close to the connector as you can. The more wire you leave untwisted, the more interference sneaks in, and on Cat5e and Cat6, that quietly costs you speed. Slide a boot onto the cable before you crimp. It shields the little clip from snapping off. And always test the finished cable. A cheap RJ45 tester lights up pins 1 through 8 in order, so a swapped or dead wire shows up in seconds. A note on power. Power over Ethernet, or PoE, sends power down these same 8 wires to cameras and access points, with no separate adapter. And remember, this is low-voltage data, not mains. Unlike a wall plug, the cable itself is safe to handle. 2 quick calls to finish. Solid core cable is for long in-wall runs. Stranded is for flexible patch leads. And if you would rather skip crimping, punch the same 8 colors into a keystone jack. Identical order, no plug needed. Everything you have seen is drawn in a free editor that runs in your browser. No install, no login. The idea behind Ethernet is the same idea behind any circuit. A signal needs a complete path. Here is a source, a wire, and a load. Break that loop anywhere and nothing flows, exactly like one wire out of order at the plug. Open the symbol library, search for connectors, plugs, or any of 400 parts, and drop them onto the canvas. This is the honest way to learn wiring. Stop watching, open a blank diagram, and build one yourself. So here's the whole thing in one breath. An Ethernet cable is 4 twisted pairs, 8 wires, in orange, green, blue, and brown. They sit in a fixed order at the RJ45. T568B on both ends for a normal cable. Clip down and away, pin 1 on the left. Strip, order, trim, insert, crimp, then test it. Get the color order right, and every Ethernet cable after this one is muscle memory. Open circuit diagram maker.app, grab the symbols, and draw it yourself. It is free, it runs in your browser, and the link is right below. Subscribe if this made RJ45 wiring finally click, and I will see you in the next one.